Hey Opties! Today we're having an intro to rationals, including expressions and equations, and we're going to be looking at the difference between those and how to simplify expressions and solve equations. So let's get started. First off, we have a definition of a rational expression. That's a quotient, which means you're dividing, of two polynomials, meaning a fraction that can have variables in the numerator and or the denominator with real coefficients, so no i's in those numbers in front of the variables, and whole number exponents, so no fractions in the exponents and no negatives. And expressions versus equations, the main difference is that there's no equal sign in expressions. So let's take a look at a very important part of rationals. This is called restrictions. Remember, if you're dividing, there's something that cannot happen in your denominator. You can't divide by 0. Okay, that's called being undefined. So restrictions or being undefined, those kind of go hand in hand. So since we cannot divide by 0, any value for a variable in our rational expression that makes the denominator equal 0 is called a restriction. And the way that we represent that is by saying x cannot equal that number, because that number would make a 0 denominator. We find these by setting our denominator equal to 0 and then solving that little equation we make there. So we're really finding those zeros. If you think back to quadratics, we had multiple ways to solve for zeros, and that's what we're talking about here. But it doesn't have to be just a quadratic. Sometimes they're just linear. Let's take a look at simplifying by simplifying common factors to 1. This can also be talked about as monomials, which is just like one term. So common factors are common monomial factors. So let's look at a number example. We have 2 times 3 divided by 3. Of course, we know 2 times 3 is 6, and we know 6 divided by 3 is 2. But if we look at it with the numerator being broken down as 2 times 3, we can see that 3 divided by 3 is 1. So this is the same thing as 2 times 1, which of course is just 2. So that's how we can simplify that. Example A is our first example of simplifying a rational that actually has variables in its numerator and denominator. So you might look at this and think, ooh, I want to distribute my x, which wouldn't be incorrect, but it's actually counterproductive, because what you want to do is get it simplified. That would be like distributing it out. That would be like getting it more complicated than what it is. It's actually already been factored for you. That's why it has that x on the outside of the parentheses. So notice your x minus 1 and your x minus 1 are both part of your numerator and denominator. So that's kind of like your 3 and 3. Those can simplify to 1. So we see that since those simplify to 1, it's going to be x times 1, like we had 2 times 1, and that's of course just x. So that simplifies all the way down to just x. So resist the urge to distribute unless you're going to be solving, and you might want to do that sometimes, and we'll talk about that in a moment. Our second example is simplifying by factoring. So we don't already have a factored expression here. It needs to be factored. Unlike our first example in example A, it was already factored. So let's look at our number example. So to find our common factors, we want to break down 18 and 12. So 18 could be broken down into 6 and 3, and 12 could be 3 and 4. Now that takes out one common factor, but then we can look at our 6 and our 4. 6 can be 3 times 2, and 4 can be 2 times 2, which we see we have another common factor of 2. So that goes away as well. It simplifies to 1. And now we have our final answer of 3 divided by 2. So you do this sort of thing all the time, and it's really not much different in our process for simplifying our rational expressions. It just looks a little bit crazier because we've got a bunch of variables in there, but it's really the same thought process. So let's look at example B. We want to simplify x cubed minus 16x divided by 2x squared plus 2x minus 24. So remember, when we're factoring, we want to start by trying to find a GCF if there is one. there is one in the numerator and the denominator. So we're really treating the numerator and denominator separately at first to factor each piece. So the numerator, we can factor out an x, and then we have x times x squared minus 16. On the denominator, we can factor out a 2, that's our GCF, and then we have x squared plus x minus 12 left on the inside. Notice that x squared minus 16 is a difference of squares. Since x squared is a perfect square, you're subtracting, so there's that difference, and 16 is a perfect square. So remember to factor that, it's a plus b times a minus b. So the square root of the first term is your a, or the positive square root, and the positive square root of your second term is your b. So it's going to be x plus 4 and x minus 4. So we're completely done with factoring our numerator. Let's completely finish factoring our denominator. This is a trinomial quadratic that has a equal to 1. So we're going to try to factor. So we have to decide, are there any factors of negative 12 that add to positive 1? And there are. So let's keep our 2 out here. So what are those factors of negative 12 that add to positive 1? That would be our positive 4 and negative 3. So x plus 4 and x minus 3. Notice we have x plus 4 in the numerator and denominator. That simplifies to 1. So finally, our final simplified version of this is x times x minus 4 divided by 2 times x minus 3. And typically you don't want to simplify this by distributing, because that would be considered less simple, because you see how it was not factored at the start. You want to leave it in factored form. So let's not forget about our restrictions. We do have a denominator in our final simplified version of this. So we have to consider, are there any x values that would make this denominator equal 0? Okay, so let's take this denominator and set it equal to 0 and solve. Well, if we set that equal to 0, we could divide both sides by 2, and then we just have x minus 3 equals 0. X minus 3 equals 0. And if we add 3 to both sides, x equals 3. But to write our final restriction, remember we have to write that x could not equal this number. So we're figuring out the 0, but it cannot equal that, because that would make our whole entire denominator 0, and that's a big fat restriction. So we have to say x cannot equal 3, because if it does, that's 2 times 0, and the whole denominator is 0, and that cannot happen. We cannot divide by 0. So that's our restriction. So don't forget to include your restriction if you do have a denominator in your final answer. One thing I do want to mention is our original denominator also has to go in with our restrictions here. So even though it's simplified to 1, we still have that x plus 4 piece that has to be considered to equal 0 as well, and what cannot be equaling 0 for our x value. So what value of x would make x plus 4 equal 0? That's going to be negative 4. So we can also include x cannot equal negative 4. So let's write both of them over here. X cannot equal 3 or negative 4. And those are our restrictions. Let's take a look at equations. So a rational equation is just an equation that has at least one rational expression in there. So we've got some fractions happening. And it could be a fraction plus a fraction equals a fraction minus a fraction equals a fraction, or multiplying or dividing. But for our examples here, we just want to look when one fraction equals one fraction. And when we have that situation, we solve by cross multiplying. So let's look at example C. We want to solve 2 divided by x minus 1 equals 5 divided by x plus 2. Recall that cross multiplication means you're going to multiply the first denominator times the second numerator, and the first numerator times the second denominator. It's called cross because we're multiplying the numbers or expressions that are across from each other. And we make a little cross. when we're multiplying. Some people like to draw these circles. I'm going to do it the first time just to remind you of this. So the reason you do cross multiplication is because if you want to get rid of the x minus 1 denominator on the left fraction, you would multiply both sides by x minus 1. And that's exactly what you're doing. And if you want to get rid of the second denominator, x plus 2, you multiply both sides by x plus 2. The reason you don't have to think about multiplying it by every piece is because on the right-hand side, the x plus 2 was simplified with x plus 2. And on the left-hand side, when you're multiplying, you're really just multiplying those numerators, and your x plus 2 would be over 1. So here's how we do it. Let's go ahead and show our next step. 2 times x plus 2. Notice I'm putting the x plus 2 in parentheses because it is a binomial. It's not just a monomial, which means to be one term. It does have two terms. So we want to make sure we're going to put it in parentheses so we show that 2 is going to be eventually distributed. Now that equals 5 times x plus 1, again in parentheses. Now we want to do distribution. So we're going to distribute our 2 to get 2x plus 4. Still have our equal sign. Distribute our 5x plus 5. And now we're going to solve this. So let's get our numbers together. We could subtract 4 from both sides. Now 2x equals 5x plus 1, and we could subtract 5x from both sides. Negative 3 equals 1, or negative 3x. And then we divide both sides by negative 3. And x is equal to negative 1/3. Okay, so we're done with that one. Notice that we only had a highest exponent of 1 for x. We didn't have any quadratics, but we will have that in this next example because notice when we cross multiply, we're going to have an x times an x, which will give us x squared. So cross multiply, then solve the quadratic. So this is whenever you have an x in your numerator and denominator for at least one fraction, but if for both, it's definitely going to be the quadratic. So let's do our cross multiplication. I'll go ahead and draw the bubbles again just to help us out. X minus 3. Now, they're both binomials, so we want to put both of them in parentheses. That equals x plus 1 times x plus 4. Now, when we have two binomials that are being multiplied together, we distribute, but we make sure we're multiplying each piece by each piece. So x times x is x squared. X times 2 is 2x. Negative 3 times x is negative 3x. Negative 3 times 2 is negative 6, and that equals x squared plus 4x plus x plus 4. And that's what I did real quick right there. Okay, combine like terms, x squared, and then 2x minus 3x is minus x. We have our minus 6. We have x squared. Positive 4x plus x is positive 5x, and then we have our plus 4. Okay, remember when we solve quadratics, we want to make them equal 0. So we're going to subtract x squared from both sides. Those are a 0. And then we'll add our x to both sides. Negative 6 is equal to 7x plus 4. Subtract 4 from both sides. We get negative 10 is equal to 7x. Divide both sides by 7. And x is equal to negative 10 over 7. So that's our solution there. And notice that we didn't actually have to solve the quadratic because our x squared term simplified to 0 because we had just x squared on both sides. But what if we had, instead of x minus 1, we had 2x minus 1? That's going to give us not just an x squared and an x squared, but that'll give us where we still have a quadratic. So when you see an x in the numerator and denominator, or when you're solving with cross multiplication, make sure that you're keeping in mind that if you do get a quadratic, you do solve that quadratic. Remember all of our methods: quadratic formula, factoring, and so on. All right, Opties, that's it for Intro to Rationals with Expressions and Equations. See you next time.